Well, hello Internet, and welcome to part 18 of my C++ video tutorial. In this part of the tutorial, I'm going to cover all of the associative containers as well as all the container adapters and also present enums. Like always, all the code, which is heavily commented, is available in the description underneath the video, and if you haven't watched any of the previous tutorials, you probably should, otherwise you may be confused, and I have a lot to do, so let's get into it. Alright, so here we are, and you can see all the libraries I'm using. These ones are going to be specific to this tutorial, of course. And those are going to be everything you need. You can pause the video and copy those out or go and get the code. So what is an associative container? An associative container is a container that just stores sorted data, and what makes them different from previous that we have seen is that since the data is going to be sorted, it is going to be slower to insert the data, but it is going to be much faster to search for the data. So the very first one I'm going to cover are sets. So let's go and create one. And you're going to define the data type. You can put any data type in there that you would like. So I'm just going to call this set1. And they are going to store unique sorted data. So let's go and try to put something in here that isn't unique and see what happens. So there we go, and I just created a set. Now you're going to be able to come in and get the size of our set and output that, and you can see right there I put 6 values in there, and you can make an educated guess to how many values it thinks it contains, and throw a new line in there and run it, and you will see that 5 comes back. Why did 5 come back? Well, because we got rid of the additional 1 we have inside of there. Now let's go and print this out. First, what I'm going to do is I'm going to verify that our set is not empty. And then if the set is not empty, then I am going to print it. So what I'm going to do is I am going to say for int I and set1, and then go and print out all of the values stored inside of our set. So here we go, and there we go. And now you will see that not only are they sorted, but the additional 1 we tried to put in there was kicked out. Let's go and do some more things with sets. Well, one thing that would be useful is to be able to insert new values inside of it. And guess what we use to insert? The term insert. So there we go, and now you'll see it's there. And it's also sorted, just like we would expect it to be. Another thing to note is that our subscript operator is not going to work for us. So for example, if I tried to go set1 and then I threw 0 in there to supposedly get the very first value inside of it, I'm going to run it and you're going to see I get an error. And what does it say? It does not provide a subscript operator. So how are we going to get our values out of our sets? Well, I will show you. So to get the values out of a set, what you're going to do is you're going to need to use an iterator. And of course, it's going to have exactly the same setup that we have with our set that it's going to be working with. And I'm just going to call it IT, and I'm going to set it to the very beginning of our set. Then what I can do is I can increment the iterator if I would like. And now I can go in and print out the value that I have set with the iterator. So this would be the second value inside of there since I iterated it forward. And then I can go and get the value that is stored inside of it. And you can see whenever I run it that it gives me the value of 1. And you can see right there is how we get our index. So very useful stuff. Also, I can come in and erase a value. So let's say I wanted to specifically erase 5. I did that. I could also come in and erase the last 2 values. So I'm going to use an iterator once again to do that. So I'm going to go in here and I'm going to go end to go to the very end of our set. And then I'm going to use advance, which I have covered in previous parts of the tutorial. And again, just put the iterator inside of there. And then -2 would get us to the 2 spaces in from the end. And then I can go set1 and once again erase, and then pass in the iterator, and then where I want to erase to, and that's going to be to the end of our set. And there you can see those values disappeared. I'm also going to be able to add multiple values. Let's go and create ourselves an array here. and I'm just going to go 6, 7, and 8, and why don't I throw 9 inside of there? All right, so I got our array set up. Then what I can do is just go set 1, and remember it doesn't matter positioning wise because it's going to automatically sort everything, and I have to say how many values I want from the array, and I do that, and everything is working again. You can also come in and find values. So I'm just going to go auto to have the data type automatically generate. And then I'm going to go set 1. And I'm going to say that I want to find 6. I'm then going to come in and I can say found and go and get our value out of that guy. And you can see that we found the value of 6 that we were searching for. There's also a guy called lower bound, which is going to get you whatever you were pointing at. So it's going to give you the iterator to that specific value. So let's say I go and use 8 inside of here, and I go set 1. And what I want to specifically find is lower bounds for 8. I can then come in and print that out. So I'm just going to put, I don't know what makes sense to put inside of here. I'll just put 8 inside of there. And remember, that's the iterator, but I put a star in front of there, and that's going to actually get me the value itself. And there's also another one that is called upper bound. Let's just go and copy this just to save a little bit of time. What it's going to do is it's going to get me the iterator that follows what I put inside of there. So I'm going to say upper bound. And then let's change this to 9, and then let's change this to 9. And there you can see we also got that. We're also going to be able to go and swap values between sets. And to do that, I need to go and create another set. And they're going to have like data types, obviously. So let's just say I have 10 and 11 inside of this guy. And then I want to go and swap those values. I can just go swap and then go set 2, which is what I just created inside of there. And you're going to see those values right there. And there you go. That is a quick rundown of sets. And now what I want to do is talk about multisets. Now, a multiset is going to be able to do all of the things I just showed you that the set did. However, it is also going to be allowed to contain duplicate values. So that is really the only way they are going to change. And I can prove that to you if you, for some reason, wouldn't believe what I was just saying. All right, so there's a multi-set that we just created, and I called it mset1. Let's just go change that to mset1 and change this to mset1. And everything else is exactly the same. So let's say I wanted to insert some values. I'm going to go mset1 and insert. The values are, of course, going to still be in order, but they're going to be sorted. But there we are, and let's throw a 0 inside there just to do something, and then let's run it, and you're going to see that they are all in order, even though I went and added different values, but there's the duplication in regards to the value of 1. All right, and since multi-sets do all the same things as sets, I'm not going to waste your time covering those over again. Instead, I'm going to talk about maps. All right, so if you'd like to create a map, basically a map is just going to store key value pairs. And one thing that's important to know is you cannot have duplicate keys. If you wanted to create one, you just go standard map. Then you're going to define whatever your key data type is going to be, and then what is going to be stored as your value, which I'm going to put in here as a string. I'm just going to call this map1 just to keep it simple. We're going to be able to add values inside of it using insert once again, and you're going to have to come in and put standard pair like that. Then you're going to put in your key, and you're going to put in the value data type once again, and then whatever information you want to store inside of there. So that is the key, and then you will see that is our value. And remember, you're going to have different keys for each one of these. So let's just go and throw those inside of there, and then we can come in and say Lisa and Marge and Homer. Just some names I just pulled out of a hat. Of course, I have no idea who these people are. And there we go. So I got those all inserted. If you're going to want to print out these items, you're going to have to use an iterator. So I'm going to come in and create that, of course. and int and string and iterator, it2. And let's just get rid of this all together. There that is, and it's gone. All right, and now to cycle through and print out both the key as well as the value, I'm gonna go and use our iterator, and I'll assign it to map1 and the beginning of it. And then I'm gonna say it2 is not equal to, and the end of our map that we have here. And then I'm going to just increment it each time through. Now, if I want to go and get our key, I'm just going to put key inside of here just to label that guy. What I'm going to do is go point at our iterator, and then I'm going to say first, and that is going to get me our key. I have no idea why they chose first instead of using key, but you know, whatever, the person that set this up, that's what they did. All right, what else are we gonna do? We're also, of course, gonna want to get our value. So throw value inside of there and then take a wild guess what this is. No, it's not value, it is second. All right, so there that is. And if I run this, let's see, you're gonna see that it prints out all of the keys as well as the values for everything that we inserted into the map. So what are some other things we can do with maps that are useful? Well, we'll be able to find elements using the key. So I'm just going to call this match is equal to map1 and then find, and then you'll put in the key that you're specifically looking for. And then we can come in and get the match, which is going to be, whoops, we're going to use second to print out the value if we'd like to do that. And you can see Bart prints up right here, okay? We're also going to be able to use lower bound like we did before to get an iterator to a match. So I'll say map1, lower bound, and then the specific key that I'm looking for. And then let's just label this LB for lower bound. And then if I want to get the actual value there, I just go Bart and second. And then, of course, if I can get the lower bound, I can also get the upper bound, which is going to be the thing that comes, the value in this situation that comes directly after that. So we'll just change this into Lisa because we know that's who's next. And then we'll change this to upper, and then we will change this to Lisa again. And then we'll change this to upper bound. And if we run it, you'll see that Bart and Lisa show up just like we would guess. And that's basically all of the things that you can do with maps. So now what I'm going to do is talk about what differs with a multimap. Basically, the only thing that differs is that a multimap is basically like a map, except you can have duplicate keys as long as the values are different. And how we define one is we go multimap like that. And I'll just call this mmap just to keep that straight. And then what I'm going to do is I'm going to throw in another value here, and I'm going to get rid of Homer, and just let's get rid of all this. We know this works. And let's go and print out those values. Change this to 3 just so that if you're working with this code, you are not going to have any problems with having the data types in the same file. I just do this to help you from having any other errors. Just change this to 3, change this to 3. And then this is going to be multimap and multimap. And I think I caught everything. And if we run it, whoops, what did I miss? Oh, I know what I missed. Multimap, multimap, multimap. Save and run. And there you can see we were able to get those values even though we had the same exact key. All right, and everything else is going to be exactly the same in regards to multi-maps in comparison to maps. So now what I want to do is talk about container adapters. So what is an adapter container? Well, basically, it is just a container, a place to store data that is going to provide a defined interface. For example, stacks provide an interface for storing elements in a last in, first out format. And you may have heard of that before, or you may not have. I am going to show you what that means. Basically, it means that the last item you put in is going to be the first one that gets pulled out. Okay, that's pretty much what it means, exactly what it says. So I'm going to show you an example, and then it'll make total sense. So what we do is let's say we have like a customer database. What I want to do is I want to push on some different values onto our stack. And then I'm going to go, here is a family, and if you can guess who this family is, then put it in the comment section below, and you will get absolutely nothing, but I'm just interested to see if anybody's willing to do that. Alright, so I just threw that right there. There's 3 people that I threw onto my customer database. Now I'm going to be able to do things like get the size of our stack, the total number of values, and that's going to be very useful. I am then going to print them out. Stacks are very simple. So I can go and check if our customer's stack is empty or not, right like that. And then what I can do, if I want to cycle through said values, I'm going to go like this. And I'm going to say, well, I is less than size. Whoops. And then I'm going to increment I. And now if you would like to come in here and get the value out of the stack, you can do so just by going customers and top and a new line. And that is going to give you the top value, but it is not going to remove it from the stack. So to remove it from the stack or delete that value from the stack, you're going to go like this, and you're going to say pop, not top, pop. There we are. And there it is, and we can run it, and there you can see that they came out. See, last in, we put George, Louise, and Florence. First out, Florence, Louise, and George. All right, stacks are very simple. I just covered them right there. And now what I want to do is talk about a queue, which is almost exactly like a stack, except it is first in, first out. And there's no real point in changing that many things here. Let's just go. There's queue, and we are going to have strings inside of it. I am instead going to call this cast, and let's see if anybody can guess who these people are from. So I'm going to go Zoidberg, Bender, and Leela. All right, so we got those inside of there. I am then going to change this to size 2. I'm going to change this to cast. And then I'm going to be able to cycle through these once again. So I'm going to say cast and check that if it is empty or not. All of this is going to stay the same, except this is going to be changed to size 2. I am then going to change this to cast. This, instead of being top, is going to be front. And then this is going to remain pop, just like it had before, except you have to change that to cast and run it. And what I do, oh, I am a silly guy. Have to change these to cast as well. And we run it, and you can see, just like we said before, this is a first in, first out. Zoidberg went in first, Bender, Leela, and then first in, first out, Zoidberg, Bender, Leela. Okay, there you go. Queues, pretty simple. And now I want to talk about the difference between a queue and a priority queue. Basically, the only difference is elements are going to be organized with the largest first inside of a priority queue. So let's just go and create one. Priority queue. You're going to have to put a underline there. And here I am going to change this to ints. So there's that. And we'll change this to nums. We are going to use push once again, but of course I have to change this, all of these guys, to nums. Don't want to make a mistake like I did last time. I'm going to be able to get my size once again. Change that to that. Change this to nums. I am going to be putting integers inside of here, so I'm going to, on purpose, put these in the wrong order. So I'm going to go 4 and 8 and 5 just to show you that they are sorted. And then I can go and check if it is empty again, just by going nums empty. Change this to size 3. Take a wild guess why I am going and getting the size outside of the queue, as well as I did with the stack and the query. That can be good homework for you, a little thinking exercise. Then if I want to go and get these individual values, I'm going to go nums, and I'm going to say top to get those values out. And then nums again, and pop to remove them from the priority queue, and run it. And you will see that it put the largest value at the top and the smallest value at the bottom. And that is the only difference between a queue and a priority queue. And now to finish off this tutorial, I'm going to talk about enums. Now, basically, an enum is just a custom data type that assigns names to constant integers so that a program is more often than not easier to read. So what I'm going to do here is define a enum. and I'm going to call it day. And you're going to be able to define starting indexes and also other indexes anywhere else within it. So we're going to say mon, and here I will give it an index of 1, and then it'll increment. Tuesday we'll get 2, obviously. Wednesday we'll get 3, and Thursday we'll get 4, and Friday would get 5, or I could put a 6 inside of there if I would prefer to have it get a 6. That's okay. You can do either if you would like. There's no reason I can imagine that you'd want to do that, but hey, what the heck. Then what we're going to be able to do is assign these values. So we'll just go twos like that, and then we can output some information. So we'll say Tuesday is the, and then Tuesday, and that would represent second day of the week. Okay. And then we could also come in here and cycle through our days by going int I is equal to Monday, and while I is less than or equal to Friday, and then we could increment the value of I, and then output all of those numbers on our screen. And there we go, and we can run it, and you will see that it went and printed out all of those values. Okay, so hopefully you guys found this tutorial useful. In the next part of the tutorial, I'm going to cover regular expressions. And like always, please leave your questions and comments below. Otherwise, till next time.